We are going to start now lecture 8 of chapter 7 class 11th mathematics, permutations and combinations. The first topic we have, it is number of divisors of a number n. We have to count this. So the first result we have over here, it is every natural number n can always be put in the form, we are talking about this form, where p1, p2, p3, pk are distinct primes and alpha 1, alpha 2, alpha k, they are the whole numbers. So we are saying that every natural number, it can be written as the product of the prime powers. So the total number of divisors, we are saying the total number of divisors of n including 1 and n, it is, we are saying these powers we are talking about, it is alpha 1, alpha 2, alpha 3, alpha so on up to alpha k. So answer we have, it is alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 so on up to alpha k plus 1. So suppose we have a number which can be written in the form, say 2 raised to the power 3 into 3 raised to the power say 4. So what we are saying over here, that if we want to calculate the total number of divisors, we are saying that 2 can have 2 and 3, we have these two numbers. The options we have for this power, it is, we are saying this power can be 0, 1, 2 or 3. So total options we have, it is 4, and for the options we have for the power of 3, it is 0, 1, 2, 3 and 4. So the number of options we have, it is 5. So this is mentioned over here, that is alpha 1 plus 1, this is alpha 2 plus 1. So the answer we have, that is equal to 20. Next is the total number of divisors of n excluding 1 and n. So we are saying the total number of divisors we have these are including 1 and n. So if we exclude 1 and n from this, we are saying basically that we have excluded these two numbers. We have done over here, it is minus 2. Next is the total number of divisors of n excluding either 1 or n. One of the 1 and n is excluded, so we are subtracting 1 from this term. We are saying we are subtracting 1 from this term. So this will give us the answer that either one of these two will be excluded. Next is we have to calculate the sum of all divisors. So if we are talking about the sum of all divisors, we are saying the values we have. So suppose again we are talking about a number is there, it is of the form 2 raised to the power 2 and 3 raised to the power 3. So the divisors we are saying, if we are talking about all the divisors, we can write them in the form, it is 2 raised to the power 0, 3 raised to the power 0, then 2 raised to the power 0, 3 raised to the power 1, 2 raised to the power 0, 3 raised to the power 2, 2 raised to the power 0, 3 raised to the power 3. Next we will have 2 raised to the power 1, 3 raised to the power 0, 2 raised to the power 1, 3 raised to the power 1, 2 raised to the power 1, 3 raised to the power 2, 2 raised to the power 1, 3 raised to the power 3. Next we have, it is 2 raised to the power 2, 3 raised to the power 0, 2 raised to the power 2, 3 raised to the power 1, 2 raised to the power 2, 3 raised to the power 2, 2 raised to the power 2, 3 raised to the power 3. So these are all the divisors we are saying. Now if we have to calculate the sum of all these divisors, so what we can see, if we add all these values from this first column, we obtain it is 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2, and common term we have, it is 3 raised to the power 0. Similarly from this second term, if we look at this term over here, we are writing, suppose this value as, k, then the second value we will have, it is k into 3 raised to the power 1, then the third value we have, it is k into 3 raised to the power 2, then the next value we have, it is k into 3 raised to the power 3. If we take k common, we are saying it is 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2 into, we are left with this 3 raised to the power 1 plus 3 raised to the 0, 1 plus 3 raised to the power 2 plus 3 raised to the power 3. So similarly, if we generalize this result, we have the general result in the form that the sum of all these values, it is p1 raised to the power 0 plus p1 raised to the power 1 plus p1 raised to the power 2 up to p1 raised to the power alpha 1. Next is p2 raised to the power 0 plus p2 raised to the power 1 plus p2 raised to the power 2, so on up to p2 raised to the power alpha 2. And likewise, if we continue the last term, we will have it is pk raised to the power 0 plus pk raised to the power 1 plus pk raised to the power 2, so on up to pk raised to the power alpha k. And these sums we are saying, these sums if we look at, these are the finite GPs. This is sum of finite GP, and the formula we have it is 1 minus p1 raised to the power alpha 1 plus 1 by p minus 1 into this term. So this is the sum of all the divisors. Next is sum of proper divisors, that is excluding 1 and the expression itself. So it is sum of all the divisors. We already have the formula over here. From this we have to exclude two numbers 1 and n. So we are subtracting the sum of these two numbers from this sum and we obtain the answer. Next case we have is the number of even divisors, and the divisor will be even if we are saying that the value 2, it is a factor of this number. So we are saying the factorization in this case, it will be 2 raised to the power alpha 1, then some prime p2 will be there whose power is alpha 2, so on up to some prime pk is there whose power is alpha k. So the number of prime factors we will have, we are saying this alpha 1 is there, this power cannot be 0. So we are saying that we have alpha 1 options over here. We are saying the values of alpha 1, these can be 1, 2, 3, so on up to alpha 1. From these numbers we have to choose, because the number is to be prime. It means that the value of alpha 1 we cannot choose it equal to 0. Now rest of the numbers we can choose any number over here. So we are having alpha 2 plus 1, that is the values of alpha 2, these can be 0, 1, 2, so on up to alpha 2, any value we can choose. So on up to the last value we will have it is, this term we will have it is alpha k plus 1. And this plus sign, it is not over there. We are saying it is product of all these terms. That will give us the number of even divisors of n if it has even divisors. We are saying the value of p, that should be equal, p1 should be equal to 2. Next is the number of odd divisors when we are saying. So we are saying if p1 is equal to 2, then the number of odd divisors we will have, p1 means we are talking about we have alpha 1, p1 raised to the power alpha 1, p2 raised to the power alpha 2, so on up to pk raised to the power alpha k. Suppose we are saying that it has this value 2 is there and its power is alpha 1. It means this value we are talking about, it should be alpha 1 should be equal to 0. So there is only one option from which we can choose the value of alpha 1. We are saying there is only one value from which we can choose the value of alpha 1. Then alpha 2 we can choose, it is alpha 2 plus 1 ways, so on up to alpha k plus 1 ways. So the total number of ways we have it is alpha 1 plus 1, alpha 3 plus 1, so on up to alpha k plus 1. Second case we are saying if p is not equal to 2, then when p is not equal to 2, it means that we are talking about, we have this value and this p1 we are saying it is not equal to 2. It means 2 is not a factor of this term. It means whatever powers we take, it is always odd number because 2 is not the factor of this term. So we are saying the number of options we have it is alpha 1 plus 1, alpha 2 plus 1, alpha 3 plus 1, so on up to alpha k plus 1. Next is the number of ways in which n can be resolved as a product of two factors. So we are talking about two cases over here. One case we are saying when n is a perfect square, and another case we are saying when n is not a perfect square. So when n is a perfect square, we are talking about the number of the form, say it is 3 raised to the power 4 into say 5 raised to the power 6. In this case the number is a perfect square, both these are even. So this is the perfect square of the number 3 raised to the power 2 into 5 raised to the power 3. This is perfect square of this term. So we are saying that if we want to calculate the number of ways in which this number can be resolved as a product of two factors, Now the total number of factors we can have, we are talking about this case, the total number of factors we can have, it is 4 plus 1 into 6 plus 1. So we are saying the answer we have, it is 5 into 7, that is equal to 35 divisors are there. There are 35 divisors. Now if we want to calculate the factors corresponding to this, suppose we are saying out of these divisors we have chosen one element. Say it is 3 raised to the power 2 into 5 raised to the power 4. We have chosen one element from this. Then corresponding to this element, the second factor we will obtain automatically, that will be 3 raised to the power 2 into 5 raised to the power 2. It means that how many different these numbers, these first numbers we are talking about, how many these numbers we can choose from these different numbers we are talking about. So it is 35 plus 1 by 2, that is equal to 36 by 2, that is equal to 18. So we can choose these 18 numbers, and corresponding to these 18 numbers we will obtain the remaining numbers over here. We will automatically obtain the remaining numbers over here. So we are saying that if n is a perfect square, then the number of, or n can be resolved as a product of two factors in 18 ways. This thing can be generalized in this way. We are saying that both these numbers are even. So we are writing it is alpha 1 plus 1, alpha 2 plus 1, so on up to alpha k plus 1. This is the total number of terms or total number of divisors that we have. Then this whole term, it is odd. We are adding 1 to it and we are dividing this whole term with 2. You can see over here that we are dividing this whole term with 2. This will give us the answer when we are saying this is the, in how many terms, in these many terms the product can be resolved. Second case we are talking about, it is that the number is of the form, say it is not a perfect square, we have 3 raised to the power 4 into 5 raised to the power say 5. Then how many factors we will have? It is 4 plus 1 into 5 plus 1, that is equal to 5 into 6, that is equal to 30. Now out of these 30 items we have to choose 15. These first numbers we are saying we have to choose 15, and the second factor we are saying that will be automatically obtained. That second factor will be automatically obtained. So we are saying that if n is not a perfect square, then the total number of ways of choosing the factors, or total number of factors in which it can be resolved, number of ways in which it can be resolved, it is 1 by 2 into the total number of divisors that number has. Now based upon this we have certain questions, certain problems. So first is find the number of proper factors of the number 38808. Also find the sum of all these divisors. So if we write the prime factorization of this number, it is 2 raised to the power 3 into 3 raised to the power 2 into 7 raised to the power 2 into 11. We are talking about, we will write 38808. We will start the prime factorization. We will obtain it as 19404, then 2, then 9702, then 2, then it is 4, 8, 5, 1, then 3 is the factor over here. We will have 1, 6, 1, 7, then 3 will have a factor, 3 will be the factor of this term. So it is 5, 3, 9, then we will have 7 is the factor of this term. So likewise if we continue, we will obtain the prime factorization in this form. Now the total number of, we are saying the number of proper factors. Proper factor means we are saying that 1 and this number is to be excluded. So the total number of factors we will have, the powers of 2 is 3. So it is 3 plus 1 into 2 plus 1 into 2 plus 1 into 11 plus, it is 1 plus 1, the power of 11 it is 1. and we have to exclude two numbers, 1 and the number itself. So we are saying the total number of factors, it is this, out of which 2 we are subtracting, and the answer we obtain, it is equal to 70. So we are saying that the total number of proper factors we have, it is 70. Next is the sum of all these divisors, these proper divisors. So the again the answer in this case, it is, we are saying the formula we have, it is p raised to the power 1 or p1 raised to the power 0, then p1 raised to the power 1, so on up to p1 raised to the power alpha, plus then product is p2 raised to the power 0 plus p2 raised to the power 1, so on up to p2 raised to the power alpha 2, and likewise we have to continue. So we are saying we are having the power of this first term, the value of alpha 1 we have, it is 3. So we are writing 2 raised to the power 0, 1, 2 and 3. Next the power we have, it is 2, so it is 0, 1 and 2. Next we have power 2, it is 0, 1 and 2. Next we have power 1, so it is 0, 11 raised to the power 0 plus 11 raised to the power 1, and we want the sum of all these proper factors or proper divisors. So we are saying that these are not the proper divisors, so we are subtracting these values. So on doing these calculation or solving these values, simplifying these terms, you will obtain the final answer in the form that the sum is 94571. Next is find the number of even proper divisors of the number 1008. So again the prime factorization of this number, it is 1008, we can write it is equal to 2 raised to the power 4 into 3 raised to the power 2 into 7 raised to the power 1. So when we are saying that it should be even proper divisor, it means that the power of 2 should not be 0. So ways of choosing these values, it is 4. We are saying the next power, it is 2, so we have to choose out of 0, 1 and 2. So the number of options we have over here, it is 3, and the last power we have, it is 1, so we have 0 and 1 we have to choose out of. So the number of options we have, it is 2, and we are subtracting 1 from it, because when we are saying that we are talking about even proper divisors, when we are talking about the even divisors, one of its divisor will be 1008, but this is not a proper divisor, so that is why we are subtracting 1 from it, and on solving this the answer we obtain, it is equal to 23. Next is find the number of odd proper divisors of the number 35700. Again this number is even, so it is not the odd proper divisor. So if we have to calculate the odd proper divisors, we write the prime factorization of this number. This is the prime factorization of this number. So we are saying that the terms with this 2 should not be there. The powers of the 2 should not be there. So there is one option only from which we can choose the power of 2. It should be 0. We are saying there is only one option. The powers of 3 we can choose out of 2 terms. It can be 0 or 1. Power of 5 can be out of 3 options. Power of 7 can be out of 2 options, and power of 17 can be out of 2 options. And again, when we are talking about the odd proper divisors, 1 is not to be included, but when we are writing, these are the odd divisors it has. So 1 is also the part of this. We are saying 1 is also odd divisor, but we require odd proper divisors. So it means we have to subtract 1 from it. So the answer on solving this we obtain, it is equal to 23. So we are saying the odd proper divisors we have, they are 23. Next is find the sum of the odd proper divisors. So when we are talking about the sum of the odd proper divisors, so it is 3 raised to the power 0 plus 3 raised to the power 1. We are saying we are not including the terms with the power with the factor 2. Next it is 5 raised to the power 0 plus 5 raised to the power 1 plus 5 raised to the power 2. Then 7 raised to the power 0 plus 7 raised to the power 1. Then 17 raised to the power 0 plus 17 raised to the power 1. This is 17 raised to the power 1. And we are talking about odd proper divisors. So it means that 1 is not to be included. So we have to subtract 1 from this answer. We are saying the value 1 is to be subtracted because we are considering only the odd proper divisors. On solving this, we will have it is 4 into 31 into 8 into 18 minus 1, and on solving this you will obtain the answer. It is 17855. So this is the sum of all the odd proper divisors. Next is, if n is equal to 10800, find the number of divisors of the form 4m plus 2. The number of divisors which are multiple of 10 and number of divisors which are multiple of 15. So if we write the prime factorization of this number, we are having it is 2 raised to the power 4 into 3 raised to the power 3 into 5 raised to the power 2. Now in this first part, we are saying the number of divisors of the form 4m plus 2. So we are talking about the numbers of the form 4m plus 2. So that is equal to 2 into 2m plus 1. It means that we are talking about the numbers which have 2 as a factor, and these terms should be odd. We are saying it is 2 over here and this odd number is there. It means the power of 2 should be 1. So the number of options we have, the number of options for the power of 2 for the exponent, we are talking about the exponent 2, we are seeing the power. We have only one option out of which we can choose, it is 1. Then for 3, the power, the number of options for this power we have, it is 4. It can have 0, 1, 2 or 3 as its power. And when we are looking at this term 5, the number of options for the power we have, it is 0, 1 or 2. So we have 3 options. So we are saying that the total number of options we have over here, it is 12. So we are saying that the number of divisors of the form 4m plus 2, that is equal to 12. Next is the number of divisors which are multiple of 10. So when we are saying that it is a multiple of 10, it means that we are talking about the factors which should include at least 1, 2. So the number of options for the power of 2 we can choose, it is 1, 2, 3 and 4. So we have 4 options. Power of 3 we can choose out of 4 options, and power of 5, at least 5 should be there. So we can choose it from 1 and 2. So we have 2 options. So the answer we obtain in this case, that is equal to 32. So we are saying that the number of divisors which are multiple of 10, it is 32. Number of divisors which are multiple of 15. We are saying the number we have, it is 2 raised to the power 4, 3 raised to the power 3 and 5 raised to the power 2. We want to write the number. We are saying we have 2, 3 and 5. We want to put the powers over here. And it's 15. It should be a multiple of 15. It means that 2 can have any power. It can have power from any of these numbers 1, 2, 3 and 4. So we have total 5 options to choose this. Next we are talking about 3. The number of options we have, or the options we have, it is 1, 2 and 3. We have to choose out of these 3 numbers as the power of 3, because it cannot be 0, otherwise it will not be a multiple of 15. So we have to choose out of these 3 options. When we are talking about 5, the number of options we have, it is 1 and 2. So we are saying we are having 2 options. So the answer we obtain in this case, it is equal to 30. So we are saying that there are total 30 numbers, the divisors of which are multiple of we are talking about the number of divisors which are multiple of 15, it is 30. Next is the number, find the number of divisors of the number n is equal to this number is given, which are perfect square. So if we look at this number, we can write this 9 as 3 raised to the power 22. So we are saying the number, the prime factorization of the number n, it is 2 raised to the power 3 into 3 raised to the power 27 into 5 raised to the power 7 into 7 raised to the power 9. Now we want the divisors of this number which are perfect square. So we are saying, suppose the number we are writing it is 2, 3, 5 and 7. All these should have even power. We are saying the options for the power of 2 now we have it is 0 or 2. Options for the power of 3 we have it is 0, 2, 4 so on up to 26. Options for the power of 5 we have it is 0, 2, 4 and 6. And options for the power of 7 we have it is 0, 2, 4, 6 and 8. So the number of options we obtain corresponding to this 2 we have 2 options. Corresponding to this 3 we have 26 by 2 plus 1 that is equal to 14 options. Corresponding to this number 5 we have 4 options, and corresponding to the number 7 we have 5 options. So we are saying the total number of options we have over here it is 560. So these are the total number of options that we can have. Next is, in how many ways the number 10800 can be resolved as a product of two factors. So if we write the prime factorization of this number 10800, we have it is 2 raised to the power 4 into 3 raised to the power 3 into 5 raised to the power 2. Clearly this power is odd. It means it is not a perfect square. This number is not a perfect square. So the number of ways of choosing in which it can be resolved as a product of two factors, it will be given by 1 by 2 into 4 plus 1 into 3 plus 1 into 2 plus 1, that is equal to 30. Now next we have is, in how many ways the number 18900 can be split into two factors which are relatively prime or co-prime. So if we write the prime factorization of the number 18900, we have the prime factorization is 2 raised to the power 2 into 3 raised to the power 3 into 5 raised to the power 2 into 7 raised to the power 1. Now to write the prime factors, suppose we have chosen this number. We are saying prime factor means we are talking about that we have to choose two numbers which are relatively prime to each other. So suppose the first number I have chosen over here it is 2. If I have chosen 2 with power 1 on this side and I will choose 2 raised to the power 1 on this side, then clearly both these numbers will not be co-prime. So it means we are not interested in this number. So what we should have is that the power of 2 should be 2 on this side and 0 on this side. We start with this, that the power of 2 we have it is 2 on this side and 0 on this side. Now we are left with these three numbers, either 3 raised to the power 3, 5 raised to the power 2 or 7 raised to the power 1. We are left with these three numbers. Now these three numbers are to be placed over here. We have either 3 raised to the power 3 will be there. We are saying it will be there or it will not be there with this 2 raised to power 2. Next we are saying this 5 raised to the power 2, we are saying either it will be at this place or it will not be at this place. Or 7 raised to the power 1, either it will at this place or it will not be at this place. So we are saying when we have fixed 2 raised to the power 2 at this place, these three options, we are saying these three numbers 3 raised to power 3, 5 raised to power 2, 7 raised to the power 1, in how many ways we can choose this? It is 2 raised to the power 3. We are saying either it can be at this place or it cannot be at this place. So what we obtain is that the number of relatively prime factors we have it is 2 raised to the power 3, that is equal to 8. So if we are talking about any general number n, if we are talking about any number n and we want to write the relatively prime factors corresponding to this number, suppose we are saying its prime factorization it is p1 raised to power alpha 1, p2 raised to the power alpha 2, so on up to pn raised to the power alpha n. So if we write the prime factorization, we choose suppose this number at this place. We have chosen p1 raised to the power alpha 1 at this place. Then what we will have, this second number p2 alpha 2, either this will be there or this will not be there. Next p3 alpha 3, it will be there, it will not be there. Likewise p alpha and this will be there or this will not be there. So how many numbers we are left now? We are talking about these numbers. These are basically n minus 1 numbers. So we are saying if this n has n relative prime factors, we are talking about prime factors means it has prime factors that are n in a number, different factors we are talking about, then the number of factors which are co-prime to each other, that will be 2 raised to the power n minus 1. So this is our general result. We are saying that the number of ways in which a composite number n can be resolved into two factors which are relatively prime or co-prime, it is 2 raised to the power n minus 1, where n is the number of different factors that we have. Next we have is division of objects into groups. So the first case we are talking over here, it is the division of objects into groups of unequal size. Now the first case we have over here, it is the number of ways in which m plus n distinct objects can be divided into two unequal groups containing m objects and n objects. So we are saying the number of options we have, this is the formula we have, we are going to derive now. It is m plus n factorial divided by m factorial into n factorial. So we are saying we have total m plus n objects. Out of these m plus n objects, first step we have to do, we have to choose m objects. So the number of ways of choosing these m objects from this is m plus n c m. When these m objects are being chosen, how many objects we are left with is, it is n objects. We have n objects now. And out of these n objects, the next step we have to choose is, we have to choose n objects. So by the fundamental principle of multiplication, the total number of ways we have, it is m plus ncm into ncn, and when we solve this we get it is m plus n factorial divided by m factorial, and the value of nc divided by m factorial into m plus n minus m factorial. So this is n factorial, and the value of this term ncn, it is 1. So the answer we obtain, it is m plus n divided by m factorial into n factorial. Next is the number of ways to distribute m plus n distinct objects among two persons in the group containing m and n objects. So it is number of ways to divide, that we have already seen, it is m plus n factorial divided by m factorial into n factorial. This is, we have factorial over here, and this term we are saying that it is to be divided among two persons. So we are saying the number of groups now we have, it is how the things can be divided among two persons, it is 2 factorial ways. So the answer we obtain, it is m plus n factorial by m factorial into n factorial into 2 factorial. Next is the number of ways in which m plus n plus p distinct objects can be divided into 3 unequal groups containing m, n and p objects is, it is given by this formula. This is just like the previous case, we are saying that m plus n plus p things are there. M are to be divided over here. When how many ways are there? It is m plus n plus p cm. How many objects we are left with is n plus p. So it is n plus p c n. How many objects we are left with is p. So it is p c p. So the product of all these values, this will give us the final answer. And further, if these three things we are saying, these are to be distributed among 3 persons. We have 3 different persons and these things are to be distributed among 3 persons. So there are 3 factorial ways to choose these 3 persons. So the final answer we obtain it is in this form, that the total number of ways we have it is m plus n plus p factorial divided by m factorial, n factorial, p factorial into the value we have it is 3 factorial. So these are the total number of ways we have. So if we generalize this result, we have the final result in this form, that if we have x1 plus x2 plus x3 plus so on up to xn distinct objects, and they are to be distributed among n persons, and each person will have to get x1, x2, xn objects, then the number of ways we have it is the factorial of this sum divided by x1 factorial, x2 factorial, x3 factorial, xn factorial into n factorial. This is just the generalization of our previous result. Now next we have is the division of the objects into group of equal size. Now we are saying we have equal size. So it is being given that the number of ways in which mn distinct objects, now the total number of objects we have it is m into n, are to be divided equally into m groups, each containing n objects. So we are saying that we want to divide it into the groups. This first group should contain n objects, the second group should contain n objects, this should contain n objects, this last should contain n objects. And how many groups we have? We have m groups. So what we obtain is, so if we look at this case, this is just like we are saying this m1 objects, we can write it as n plus n plus n so on up to, this is m times n is being added. We have total number of these objects. So if we compare it with our previous case, we were saying if we have m plus n plus p objects and we were dividing it among 3 groups, first having m, second having n and third having p objects, then the number of ways we were having it is m plus n plus p factorial divided by m factorial into n factorial into p factorial, when we are saying that the ordering of these groups is not important. Now in this case, the answer we will obtain it is, we have mn factorial divided by, we have n factorial, n factorial, n factorial. How many times we have? It is m times. So we get it is n factorial raised to the power m. And how many similar objects are there? We are saying there are total m factorial. So the final answer we obtain in this case, it is in this form. Second case we are saying, if the order of the group is important, then we have, these are the number of cases we have, and in how many ways these groups can be ordered, it is m factorial. So answer we obtain it is m n factorial divided by n factorial raised to the power m. So based upon this, these formulas, these will be more clear to you with our next problems that we are going to solve now. So based upon this, first question we have is, in how many ways can a pack of 52 cards be distributed equally among 4 players in order? So we are saying that we have total 52 cards and these are to be equally distributed among 4 players, and each player, we are saying basically 13, 13, 13 and 13 is there. And how many players are there? There are 4 players. So the answer we have over here, for the first part we are saying the answer we have it is 52 factorial divided by, in how many ways we can choose these 4 players? It is 4 factorial ways, and we are having 13 factorial raised to the power 4, and it is being given that in order. So it means ordering is important, so we have to multiply it with 4 factorial. So these two terms gets cancelled and the answer we obtain it is 52 factorial over 13 factorial raised to the power 4. So there are these many ways. Now another way to solve this is, we are saying that each player will get 13 cards. Now if we talk about the first player, we are talking about the first player, we have 52 cards. First player can get 52, see 13 ways are there in which he can get the card. Once this player has received the card, It is being given that it is in order. So we are saying that we are left with is 39 cards. So second player will get 39 C13 ways. Then we are left with is 26 cards. Third player will get it is 26 C13 ways. And then we are left with is 13 cards. So fourth player will get 13 C13 ways. So this is the stepwise process is going on over here. So by fundamental principle of multiplication, we have total number of ways. It is 52 C13 into 39 C13 into 26 C13 into 13 C13. So on multiplying this, we will get it is 52 factorial divided by 13 factorial into 39 factorial. 39 factorial by 13 factorial into 26 factorial. 26 factorial by 13 factorial into 13 factorial, and last we have it is 1. So this 26 factorial gets cancelled, this 39 factorial gets cancelled, and the value we are left over here, it is 52 factorial divided by 13 factorial raised to the power 4. So this is the final answer we obtain in this case. Second we have is, it has to be divided into 4 groups of 13 cards each. So ordering is not important over here. So what we obtain is that the total number of ways we will have it is 52 factorial by 4 factorial into 13 factorial raised to the power 4. So why we are getting this answer is, we are saying suppose now the ordering is not important. So we are having 4 groups. So suppose we are saying that with these groups, this is the first group, this is second, third and fourth. We have ordered these groups, but in this part it is being given that the ordering is not over there. So for this first case, we will have the total number of cases, it is 52C13. Then we will have it is 39C13. Then the third one will have the options, it is 13C13, and last one will have the option, it is this is 26C13 and this is 13C13. This thing we have already seen in our previous case, but in addition to it, we are being given that the ordering is not over there. So we are saying that we have to divide this value with 4 factorial, because these groups we are saying these can be interchanged in 4 factorial ways. So we are dividing this 4 factorial over here. Now the next case we have is that these 52 cards is to be divided among 4 groups, and the 3 groups we have, they should have 17 cards, and the 1 group we have, it should have 1 card. Now we are saying that this last group, it is having 1 card. So number of ways of doing this, it is the total cards we have, it is 52 cards. In how many ways we are dividing it? It is 4 ways, out of which this 1 is fixed, and we are having 17, 17 and 17 over here. So the same number of ways we have, it is 3. So we have it is 17 factorial raised to the power 3, then 1 factorial, and then it is 3 factorial. So how we are dividing this is, we are saying that the first set we are talking about, out of 52 cards, the first set we are saying it should contain 17 cards. So we will have 52C17 ways. Now when 17 cards are being used, the cards we are left over here, it is 35. So the second set we are saying we have 35C17 options. When 17 cards are being used, we are left with is 18 cards. So the third one has 18C17 options, and last we are saying we are left with only 1 card, and we have 1C1 option, that is equal to 1. So the total number of ways now we have, it is 52C17 into 35C17 into 18C17 into 1C1 into 1 by 3 factorial, because these 3 we are considering that these 3 can be interchanged. These 3 values can be interchange. So on solving this, the answer we obtain it is 52 factorial divided by 17 factorial cube into 3 factorial. So this is the final answer we obtain in this case. Next is, in how many ways can 12 different balls be divided between two boys, one receiving 5 and other receiving 7 balls. So this is the case given over here. We have total 12 and it is to be divided among two persons, two boys. One has to receive 5 and other has to receive the 7 balls. So we are saying that the total number of options balls we have, it is 12 factorial. It is to be distributed among 2 persons, 5 factorial and 7 factorial, and these 2 persons, these can be interchanged into factorial ways. On solving this, we will obtain the answer as it is 12 into 11 into 10 into 9 into 8 divided by 5 into 4 into 3 into 2 into 1 into 2. On solving this, you will get the value as 1584. Now the second case we have is that in how many ways can these 12 balls can be divided into group of 5, 4 and 3 balls respectively. So one thing is clear from here, that it is being given 5, 4, 3 balls respectively. So it means that the grouping is not important over here. So if we calculate the total number of options, we are saying we have total 12 balls are there. It is to be distributed. The first group should have 5, second should have 4 and third should have 2 balls. So the number of options we will have, it is 12 factorial divided by 5 factorial into 4 factorial into 3 factorial. If you solve this value, you will obtain the answer in the form, this is factorial over here, it is multiplication in between all these terms. So the answer you obtain, it is 27720 ways. So there are total these many ways. It is being given that it is to be distributed among 5, 4 and 3 respectively. The ordering is not important over here, and that is why we are not multiplying over here with 3 factorial. This is the reason, because ordering is not important over here. When we are saying ordering is not important, means the grouping we are talking about, that it is being fixed that this is the first place, this is second place and this is the third place, and that is why we are not multiplying over here with 3 factorial. Next is, in how many ways can 16 different books be distributed among 3 students A, B, C, so that B gets 1 more than A and C gets 2 more than B. So suppose we are saying that A gets n books. We have A gets n books. It is being given that B gets 1 more than A. B gets n plus 1 books. And it is being given that C will obtain n plus 3 books, because C is getting 2 more than B. Now sum of all these values, we are saying 3n plus 4, that is equal to 16. So we obtain n is equal to 4. So this gives us that we have total 16 books. A has to get 4, B has to get 5 and C has to get 7 books. Now the total number of options we have over here, it is 16 factorial divided by 4 factorial into 5 factorial into 7 factorial. Again these positions we are saying A, B, C, these are fixed. So we are not multiplying over here with 3 factorial. We are not multiplying over here. So the answer we obtain, it is 16 factorial divided by 4 factorial into 5 factorial into 7 factorial. So these are the total number of ways in this case.